I'm just going to say a few words just to open the event and give everyone a bit of background that is either a new LJC member or hasn't seen me talking constantly on social media about this one. But for those of you that don't know me, my name is Barry Cranford. I'm the founder of the LJC, one of the organisers. I'm not a developer myself. I'm in fact a recruiter, or I run a recruitment company called RecWorks. So what am I doing here? So firstly, I'm a huge fan of careers and all the little different things that people can do to get ahead. So working in recruitment's been pretty cool for someone like me, because you get to see everyone's careers and study what makes the differences. So our belief at RecWorks, my company RecWorks, is that recruitment can be a sort of a force of good, a power of good beyond just getting people jobs. So a lot of our work sits somewhere between giving back to people we've worked with and paying forward for relationships and people that we hope to work with in the future. So a few examples: we've run upward of 500 events for students, graduates, engineers, CTOs, all sorts of things like that. We've introduced over 2,000 mentors and mentees, and we do loads of stuff in this space where we can genuinely try to improve people's careers and lives, really. When I first set up the LJC, though, was 13 years ago, and I don't really think I knew what I was getting myself into. I had this image of a small group of developers where we could run events, and every now and again I could say, "Hey guys, I'm a recruiter if anyone needs me." And it's gone just so much bigger than that. So we're now at almost 7,500 members, and it's been quite a journey. There's loads of other things that go on within the LJC, but for me, for like something of a career geek, it's been amazing watching the careers of the people that I've met through the LJC, and watching people like Martijn and Ben Evans and Trisha G when they were developers, and seeing where they've gone. And for me, one of the biggest things that I've learned is about speaking. And to me, it's just like rocket fuel for your career. When you start speaking, even on a small scale, you start to elevate yourself above other people. And obviously, the more you do it, you elevate yourself higher and higher, internally and externally. So it leads to new jobs, it leads to internal promotions, more money, better opportunities, but it also leads to more choice of the kind of work that you can take on, which just naturally takes you closer to a career that you love. It brings you closer to people that share the same interests as you. It builds your communication skills, your leadership skills. You can probably tell I'm pretty excited about it. I could probably talk all day about it. I won't, I promise. I'll hand over in a second. But lightning talks to me are the easiest way to put your toe in the water and see if you can do it, see if you like it, see if you know it's for you. So that's what we're doing on this event. So one thing I will say just before I hand over, we've recently started a new group, an aspiring speakers group. We plan to run different kinds of opportunities for people within that group. It's much smaller, going to be like a small support group. So for example, next week we have 2 Q&A sessions set up, closed Q&A sessions with Jim Goff and Robin Moffat. Matt Rabel is going to be coming soon as well. We'll have other mentoring and all that kind of thing. I'll put a link in the notes, all completely free. So if you're interested, then just let me know, or just sign up through the form. Right, that's me done. Get out of your way. So do we have Ms. Amil? Are you with us? Yes. Great. Are you ready if I hand over to you then on getting more entropy on Linux and how random number generation causing JVM delay? Take it away. Don't know if you're on mute there, Ms. Amil?
Can you hear me now?
Yeah, can hear you now. Yeah, all good.
Okay, good. Thank you. I'd just like to share my screen first, please. Can you see my presentation?
I don't think we can actually at the moment. I can't.
Okay.
you want me to skip to César and come back to you?
No, just give me a second, please.
Okay.
So I am sharing. Can you see me now?
Yeah, got you now. Got you now.
Good. Thank you. Okay, right. So my name is Zameer Hassam, and I'm tech lead at Barclays. And today I'm going to talk about something called entropy in any operating system, but this is particularly for Linux, and how we generate random numbers in Java that causes some JVM delays if we use entropies in Linux. So that's the main topic. But first, I just like to have a few words about random generation, because that's a prerequisite to what I'm going to talk about later on. So why random generation is important? So as a developer, we often come across a situation where we need to generate some random string or random number for a variety of different reasons. But the most notable reason is the encryption and cryptography. So for example, if we are writing something like SSH hashing, or we are making a connection to the third parties, if we need to present the certificates, and we need to establish some secure connection, then the first thing which comes into play is the seed through which the random generation will be realized. And once that random number is produced, then you can use it to generate your keys, etc. So on the right-hand side, you can see a screen. It's just a very preliminary description that how the public-private key works. So you need to have a random number, a large random string, and then you use it as a seed to generate your keys, the private and public, and then the message can be exchanged using the keys, which is secured now. So that is one of the use cases of random generation. And now we see that why random generation is difficult. The true random generation algorithm means that your random number should not be predictable. That is all about randomnesses. If it is predictable, then that means it has a pattern. So then it's not random. So true random number must not be predictable, and it has no discernible pattern. But in programming, in computer science, when we use the random number, it's not true one. It's called pseudo-random number. Why? Because although it doesn't have a pattern, but you can predict it if you know the seed through which the random number is generated. So if you know the starting point, then you can use some brute force algorithms, or you can use some smart techniques, or whatever. There are papers published out there that give you some idea then how you can progress further. If you know the seed, then you can come up with a number that is generated and you can predict the next one. So this will be drastically impacting your cryptography, your encryption foundation. So for cryptographic random generation, we need a strong seed. The output must not be predictable. If you know or can guess the seed that started the pseudo number, you know all the past and future values near instantly. And it is purely deterministic mathematical function. So this should not be taken as a rant against pseudo number, that we have to live with pseudo numbers in computers, but merely as a reminder that when you use one, then the unguessability of the numbers that it splits out is only as unguessable as the seed. So you need to protect your seed first. And And why it is hard in computer science is it's an undecidable problem. If you see the complexity chart, that is NP complete, NP hard, etc. So it's an undecidable problem. And as von Neumann said, that if anyone considers that he has the arithmetic method of producing the true random numbers, is of course in a state of sin. That is just a quote I found the other day from the famous scientist. Now we come to the actual topic. What is entropy? So entropy is the measure of the number of possible choices from which your seed could be drawn. Another way to describe entropy is that it is the level, the level of predictability of the random number. So the higher the entropy, harder will be to guess the random number or the seed from where it is generated. So entropy, the unit of entropy is a bit. In layman terms, what does it mean? That if we have a fair coin and we toss it, the outcome could be head or tail. Yeah, it's a fair random event. And this is one bit of entropy. If we have two fair coin tosses, then it's 2-bit entropy. Now, the fair coin tosses is quite a natural way of getting the randomness. If we use some other way, like for example, an English text, then that has low entropy, because we have pre-knowledge of the randomness from the pool of English words we can generate from. So for example, we have only 26 alphabets, and we know that there are some rules, like the word starts with QU is more common than the word with anything with Q, anything after that. So these are the few rules which make us guess that we can apply brute force algorithms to find out the seed through which the random number is generated. There is an example of one algorithm. It's called RANDU. It's published in 1960 by IBM. And all it does is actually a formula. Now, when you give a formula to generate a random number, immediately it means that is ill-conceived random number. Because if you give a formula, that means it's a pattern. So all it works like that. If you start with any odd number, and then you fit it into this formula, and then you can generate a next number, which typically generates a very uniformly distributed number. But the thing is that when you see that long number, the human eye, it sees that it's just a random. But if you try to plot it in a graph, then you can see immediately there is a pattern there. And this is very bad for your system if you use RANDU, because it is prone to attack. You just plot your numbers on your plane, and then you can find out the starting number, and then you can, find out any number in the space, in the three-dimensional space. Now, entropy is built in the operating system in kernel level. In Linux, there are few ways through which the entropy pool is created. And as I said, that having a formula, a mathematical arithmetic operation, or to generate an entropy is a bad idea, because it will be predictable. So what Linux does is that it generates the pool from the sources through which the randomness is generated from the environment. In this example, is actually the peripherals attached to the system, which is keyboard or mouse or disk drive or other hardware events. So when you hit a keystroke, a human hits a keystroke, it can be at any time. It's fairly random event. You move a mouse, it's a random event. It's not generated from a mathematical concept. It's just that you act like that, and then you do something in your system through your peripherals, and it generates an interrupt. And so Linux harvests that peripheral events and then it feeds into a pool, which is this primary entropy pool. And then it has two methods through which the random number can be generated from the pool. It has one which is called dev random, and the other one which is called dev urandom. The dev random is a blocking method, which means that it waits for a certain time before the pool is healthy enough. If you don't have enough environmental events, if you don't move your mouse enough, for example, then your pool will be low with entropies, and the random generation generated from the pool will be of low quality. So the dev random will block until the pool is healthy enough, and then it will generate. But on the other hand, the urandom will not block. It will just generate it whatever it is given in the entropy. So this is what basically I said. I'm mindful of the time. I'm just running behind the time, so I'll just skip this one. So I've come to the Java program for the random generation. All you need to do is to instantiate this object called skillRandom, and you need to generate a byte array of certain length. For example, if you are generating a 16-digit number, you will create a 16 the byte of size 16, and then you just call the next byte method, and this byte array will be filled with your random number. Now all this looks fine, except that when you read the documentation of the skillRandom, which is here, if I can go to this link. So this is the JDK 8, and it explains that how can you generate your random number using skillRandom. And at the end, there's a small print here. It says, note, depending on your implementation, this method and this method may block an entropy. For example, if they need to read from dev random on various Unix-like operating systems. Now, it took me 1 week to understand why my JVM is slow when I was using skillRandom to number. And it was basically this, that JVM by default uses dev random, and it's all set in the java.security. So if you know your JRE, there is this file called java.security that initializes the default algorithms for cryptography, encryption, and things around that. And there is a property called skillRandom.source, which is set to file dev random. And as you know, the dev random is blocking method. When the entropy pool is low, your program goes slower. If you're running for like, I don't know, for many days, and you're generating your random numbers quite frequently, or you're using some performance testing, some load testing, and then you're hitting the pool very frequently, then it drains the pool. And the next time you might need to generate a number, it will wait, it will block. Now, it won't give you error instantly. If you have a big system and you are connecting with a database or MQ in the background, and you have opened the connection, and then you are waiting to generate your random number, it will block for some time. The connection there will be timing out, and you will start seeing some errors like the JDBC connection error, etc. And then you don't know what is happening, why it's taking long, and why the connections are suddenly, interrupted. So the take-home lesson from his is that if you need to generate a random number from the entropy, then use dev urandom, and you can do it either by changing the Java security and change this property, or you can also do it by sending a runtime JVM argument called Java security EGD, and just set it to urandom, and then you should be good.
Rossano, we're just closing in on about 15 minutes on that one. We might have to hold for the questions until maybe the breakout sessions, if you can hold on for that one. Yeah, thank you very much for that talk. Yeah, if we can all show some appreciation for Rossano. Thank you very much for doing that one. Sorry to cut in. I think we've got 7 more, so just trying to keep everything.
Yeah, sorry about that. Thank you.
That's all right. No worries. But yeah, thank you very much for that. So then, without further ado, I'll go straight over to César for the second talk on blazing fast Fibonacci with Kotlin and Arrow. Go ahead.
Yeah, you can see my screen. You can hear me. Yeah. Okay. So I'll go straight into it. A little timer. Yeah. So I'm César, senior software engineer at Thousand Eyes, and today I'll show you how to compute Fibonacci numbers very quickly using Kotlin and Arrow. So probably everyone is familiar with Fibonacci. It's the sequence of number that starts with 0 and 1, and then recursively every number n is the sum of the number n-1 and n-2. So we can implement that in Kotlin using a recursive function, and that's very naive and very inefficient because it's making 2 calls, one for n-1, one for n-2, and basically this does a lot of unnecessary work, and the complexity is 2 to the power of n, so it's very slow. It's actually also possible to do a linear implementation when you have a loop and you only remember the last 2 elements, and you can go through, and so it has a linear number of steps. It doesn't mean it's linear complexity, but I'll talk about that a bit later. But we can actually do better than that by using a bit of math. So any recursive series or sequence that depends on n-1 and n-2 with using this formula can actually be written using matrices. So if you've never seen that sort of math before, it doesn't really matter. You don't need to know that. This is just like a mathematical notation. There is a formula for doing that. But if you basically write the vector fn and fn plus 1, and you can multiply by this matrix with the vector fn minus 1 fn, and you will basically get the same relation here that you have. So what's interesting, and also you also need initial conditions. So f0 and f1, we can call them alpha beta, and we basically just create an initial vector like that. So what's interesting is that if you start with the vector fn plus 1, so we can apply the formula, but then we can also apply the formula on the next on f minus 1 fn. And then we can repeat and repeat and repeat until we get to the beginning, which is the initial condition. And basically all we have is we have the same matrix multiplied by itself n times. So we can just write that. We can just say that the vector fn plus 1 is just the matrix power of n times the initial condition. So if we move it to Fibonacci, Fibonacci A and B are 1 because it's just adding 1, and then the initial condition are 0 and 1. And what's really interesting here is that all of the work of Fibonacci is all done in here. It's just a matter of how quickly can you compute the power of this matrix. And luckily, there is a very efficient algorithm to take the power of anything, and this is called exponentiation by squaring. And it basically stems from the observation that if you want to take something to the power of n, and if n is even, you can just square that number, and now you can then you can call the function recursively on this new number, and you can divide n by 2. And if n is odd, well, it's almost the same. You do an extra multiplication, and then you take n minus 1 and divide by 2. And this is really fast because you keep dividing n by 2. So basically, the complexity you're going to do log n multiplications. So if you wanted to take 2 to the power of 1,000, instead of doing 1,000 multiplications, you would only do about 10 multiplications. So this algorithm works not just for numbers, it works for anything that has a binary operation. So if you were in the Java world, we could just create an interface. We could call it has binary operation of type T, and then our class would extend that, and it has 2 methods. One is combined, so it takes itself, another one creates another T. And we also need another method, which is empty. So empty corresponds to the neutral element. So for instance, with the numbers, it would be 1. But today I want to talk about Kotlin and Arrow. So in Kotlin, we have something called extension functions, and Arrow is a functional library for Kotlin, and it has something called type classes. So type classes, they are like the design patterns for functional programming. It's a way of thinking about them. So there is already a type class in Arrow, which is called SummingGroup, that defines a binary operation. And here, the very interesting thing compared to Java is that this semi-group is not meant to be extended by our object of type A like we would do in Java, but all the magic is all in this here. When we do a.combine, this is an extension function in Kotlin, which means that if we run code in the context of that semi-group, and I will show you how you do that later, the type A will automatically have that method as if it was defined within itself. So it adds methods to a class. And there's another one called monoid. So monoid extends the semi-group. So the column here is the extend notation in Kotlin, and we're just adding the empty. So if you're a monoid, you have the combine and you have the empty method. Once we have that, we can define the exploitation by squaring. So I don't really have time to take you through this algorithm. This is a non-recursive implementation that I found on Wikipedia. You can look at the code online, and you can look on Wikipedia. It's not that difficult. But basically here, what I do is that I called it combine times, and I'm adding this to monoid. So it means that now monoid will have combine times that takes a monoid, anything, and then a number k, and it will compute m to the power of k using the combine function. Now, because we want to do that for Fibonacci, we want to multiply matrices, so we need to define matrices. So here in Kotlin, I just define a data class. So this is like a POJO, an immutable POJO classes in Kotlin that has 4 fields for the 4 elements of the matrix. So now the final step is to define the monoid for that class. So again, we don't make matrix extend that, we just create a separate class on the side. So we just create it like that. We create a monoid of matrix. So the empty function is the identity matrix. Identity matrix is just a matrix that has 1 in the diagonal and a 0 everywhere. And if you multiply by that matrix, nothing happens. And then we need to define how to multiply 2 matrices. So again, I don't really have time to explain that. This is not really interesting. You can find it online. It's just a dumb formula that you apply. You just do a bunch of multiplications and addition. And the last line is just a little Kotlin trick so that we can quickly access the monoid. I will show you that in a second. The last thing I want to point out is that, so this is the relation that we have. So now we know how to compute that. So we can basically say that this is a new matrix that I use with notation. And this is a little trick as well. So when you multiply by vector 0, 1, effectively what it does, it only keeps the last column. So it's equal to that. So basically, fn plus 1 equals x01, x11. So if I want to get fn, I just need to take this matrix to the power of n, and then I just need to return the x01 element. So this is exactly what I'm doing here. I'm creating a singleton class in Kotlin called object Fibonacci. I'm defining the matrix for Fibonacci, which is 0, 1, 1, 1. Yeah, we've seen. And then I create a Fibonacci fast function. And then, so this is where the Kotlin magic is that we just do matrix to2.monoid and then run. So this run here, within this bracket, we are in the context of the monoid, so we can access the method of the monoid, including combine times. So we can call combine times that returns a new matrix M. And then finally, we call that, and we just return the element x01. And I'm almost done here. I just wanted to show you a quick benchmark. So here I call the linear implementation. I call it linear because it does a linear number of steps, but it doesn't mean it's linear. And here is the logarithmic one, so the one I just showed. And you can see that for really, really big numbers of n, this is getting really slow, while this one is getting fast. And I will publish today. I wrote an article on Medium that I go into a bit more details. I do a bit more explanation if it was a bit fast today. So I'm going to be tweeting that today, or you can also just check the code online on my GitHub. And that's it for me.
Brilliant, superb. Thanks, César. Everyone, any questions, feel free to hang around afterwards. We're going to have some breakout sessions, so I can put you into any room that you want to be in. But if everyone can show some appreciation and add any comments to the chat about anything that that you like there, anything you found interesting, that would be superb. Next up, we have Zameer Hassam with, I'm just going to call it faster hash tables there, Zam. I'll let you do the rest.
Right, let me just bring up the presentation. Great, can you all see that? All good? Okay, perfect. So, hi, my name is Zam. I work for a company called Transfic. Today I'm going to be talking about linear probing. This is a technique that's used for getting better performance out of hash tables under certain scenarios. So I'm going to start by talking a bit about what it isn't, which is separate chaining, which is how the standard Java HashMap is implemented. just so you have a point of comparison, and then I will be talking about the implementation of linear probing, as well as some of the pros and cons, and some production libraries if you're curious about using it. So here is something that should look pretty familiar to a lot of you. This is a standard Java HashMap. So we have a backing array structure over here. And if we want to insert into this map the keys John, Erin, Rich, and Tom, John, Erin, and Rich have different hash codes, but when they modulo by the length of the array, they end up in the same native slot in the array. So we chain them together in a linked list, and Tom, who ends up in a different native position, because when we modulo him by the length of the array, he comes into a different native slot. So pretty standard. That's how your standard Java HashMap works. So what is linear probing? Well, if we take the same data and insert it into a map that implements a linear probing strategy, it looks a bit like this. So let's say the thing is empty and we want to insert John. Well, that's kind of similar to how we did in the other example, which is that we take John, we take the hash code, modulate it by the length, and the native slot is slot number 2. Now, there's nothing in slot number 2 at the time, so John just gets inserted there. Now, the interesting one is when Erin comes along, and Erin, again, would normally be inserted in slot number 2, and in separate chaining, we would add to a linked list over there. But instead, what we do is we actually find that because the slot is occupied, we iterate to the right of the slot that we would like to go into until we find an empty slot to insert Erin into. So in this case, Erin goes right next to John. So if we want to insert Rich in, Rich would normally go into slot number 2, but it's occupied, so we iterate to the right, and then that's occupied by Erin, so we iterate to the right again, and we end up in the 4th slot. And likewise, Tom would like to be inserted into slot number 3, but we perform the same operation. So that's quite straightforward. Now, for get operations, it's kind of the same deal. So if we wanted to get Rich, for example, we would start with slot number 2, because that's where the hash code would take us, and we'd either find Rich there, or we'd keep iterating to the right until we find Rich, or we hit a null slot. And if we had null slot, then we can assume that Rich is not there. So again, quite straightforward. Start flying the ornament when it comes to delete operations from this particular map. Now, in the other example and in the standard Java HashMap, if you want to delete an item, it's deleting an item from a linked list, so it's quite simple. In this case, we can't simply null out an item. So, for example, if we wanted to get rid of Erin from here, if we did a hashmap.map.remove on Erin, if we nulled out the slot for Erin, and then try to do the lookup algorithm for Rich, which starts at slot number 2 and iterates to the right until it finds a null or Rich, that would hit the null slot where Erin was, and we would have a problem. So the way we can get around that is via one of 2 strategies. The first one is to either tombstone Erin, and by tombstoning it, putting some kind of sentinel value there, we're not nulling that particular slot, but we are removing Erin from that slot, which means that we can iterate over it and perform the same lookup algorithm, but it does mean that we are wasting a bit of space in this array. And the alternative is to do a compaction, which is that once we remove an element, we iterate to the right until we hit null, compacting any elements that would be improved if we move them back, so slightly closer to their native slot. And that works fine. So why would we want to go through this rigmarole of doing this particular technique? Well, there are some advantages to it. First is that we can get extremely fast access to our keys and values in certain scenarios. This is because we typically would implement a linear probing map by having 2 arrays, one representing the keys and one representing the values, which means that we don't have node objects in every single array slot, and we don't have to do a lot of pointer chasing. Particularly if the keys are primitive, this can be extremely fast because it would just be a primitive array for all the keys. So the probing can be very quick. This also means that we can have potentially lower memory overhead from the nodes. Since we're not actually storing linked lists at every slot in the array, we don't have a lot of node objects that are created every time we add and removed every time we do remove. We can also get extremely fast iteration over the keys or values. Again, this is particularly important if we have primitive keys or values. We can just iterate through an array of primitives very, very quickly, much quicker than we can iterate through effectively linked lists. And also, we don't have to iterate through linked lists that are joined together in an array structure, which can be particularly expensive. So the downsides of doing this, though, are that we can potentially get higher memory overhead. So we are actually using the array to store the excess of hash collisions rather than a linked list, which means the array gets a lot more full than it would in a separate chaining. And that means that we kind of need to make it a lot bigger to cope with the fact that it's going to have a higher occupancy. So typically we will resize the open addressing, either a linear probing array when it's at 50% occupancy, rather than with separate chaining, which is normally around 75% occupancy. Additionally, this can also lead to longer probe depths, because again, if we are overfilling on the 0 slot, for example, if there were 5 collisions on the 0 slot in a separate chaining map, that would mean that any lookups in the 0 slot will be slower, but any other slot would not be affected. Whereas in a linear probing map, the hash collisions in one particular slot can affect all the neighboring slots. We can also have a higher cost for removal, as I described earlier. So if you would like to read a little bit further about it, here are some libraries that I've used in the past that have implementations of these maps. The one I personally use is Agroda, which is Martin Thompson's collection of data structures which he uses in some of his projects. The code's surprisingly actually quite easy to read. A lot of these libraries have code generators behind the scenes to generate all the primitive versions of the permutations of the various different maps. This is the case with Eclipse collections, which is formerly known as the Goldman Sachs collections. The FastUtil collections, which are pretty good as well, and Trove, which is one of the oldest and probably most forked versions of these libraries. And that's the end of my talk. And here's my contact details if anyone wishes to get in contact. And I'll be happy to take any questions, if there's any time for questions, that is.
We've probably got time for one question. If there's anyone out there, feel free to speak up or raise a digital hand.
Do you have a use case where you use that, where it was more it was better than traditional Java HashMap?
Yeah, so if you have primitive keys, it can be extremely fast because your primitive array is inline in Java, so you're not paying the penalty of having to do any kind of lookups. So it can be very fast. So I definitely recommend it specifically if you have primitive keys and or primitive values. If you have primitive values as well, obviously you're going to get pretty big speed up if you're doing iteration over the values. But yeah. Oh, particular optimization as well is that in some maps, if you have keys and values that are both primitives, like a long-to-long map, what often some implementations will do is that they will store a double-sized array and store the keys in the even slots in the array and store the values in the odd slots in the array. So actually getting from the key to the value is extremely cheap.
Cool. Thanks a lot. Very nice talk.
Cool.
Thank you.
Thanks, Sam. Thank you, everyone. Please show some appreciation for Zam and add some comments down. Thank you very much for that. And we are now going to move over to Rossano D'Angelo on deploying a web app in minutes.
Hi guys, can you hear me?
Yeah, all good, all good.
Good. So let me share my screen and here we go. Can you see it? Can you see my screen? Perfect. So nice to meet you all. I am Rossano. I am a front-end engineer at Wilmington PLC. Probably I am the only one front-end engineer here today, given the topics of the previous talks. But today I'm going to talk with you about how to deploy a web application or static website on Firebase, using Firebase. So what is Firebase? Firebase is a client-side application development platform developed by Google. Its mission is to help all developers of all sizes to deploy their products, to develop their products and to put them online. So Firebase takes a lot of problems, difficult problems like deploying, securing, networking, storage, file systems, things like that, and makes them easier to solve, leaving the developer focused on the code and on functionalities mainly. So Firebase counts a lot of services, as you can see here, services that helps you building better application, services that helps you improving the quality and improving the testing of your application, and the products that helps you to grow your application, to distribute your application, and to receive and elaborate feedbacks from it, because that's important. There are a lot, I know, there are too many products, but today we are going to talk about only the hosting service. That probably is one of the most common and used, because the hosting problem it's a common problem. I mean, if you have for example, a Node.js application, there are plenty of websites platform you can host your website. But why you should go for Firebase? I think it's in my opinion, Firebase is one of the most one of the most common platforms like this, because it's developed by Google, so it's reliable. It works on content delivery networks. Your website is, when you deploy your website or your application, it is deployed in a network called CDN. So it means that wherever you are in the world, your delay it's minimum, because you're using this website from one of the nodes, spread all over the world. And Google has one of the larger networks in the world, together with Amazon AWS. Then another point is that Google Firebase Hosting Service gives you SSL certificate for free, so you get HTTPS with no cost. And as I said, it's very easy to use, thanks to a command line interface that we are going to see. So what to do to deploy a website or an application on Firebase? Third thing is to create the project. As you can see here, you have a two-step wizard that helps you to develop your project. You give it a name. You can choose to enable or not the Google Analytics service, because you have also access to the free tier of the Google Analytics services. And once done that, you can install the Firebase tools on your local machine. You can't communicate with the remote project without this tool. You can install it via npm, via brew if you have a Mac, or via the package if you have a Linux-based operating system. Once done, you can also verify if it installed, run a common -- version. It's very easy to use. And once done, you have this project. You go within this project and you run Firebase init, as you see here. This CLI will show you a wizard. It's very straightforward. Here you can see, you can pick the service you need. You have database, storage, hosting, cloud functions, Firestore, depends on what you need. I mean, if you need Firestore, if you need a database, a real-time database, you will pick Firestore, okay? If you, database. If you need storage for, I don't know, uploaded image, you will pick storage. In this case, we are going to pick only hosting, because that's what we are going to do. Only hosting a static website. As you can see here, each project, of course, has its own ways to build the deployable project. So in this case, I have a Node.js project. I run npm run build. I build the project and I run one single command, Firebase deploy. Firebase deploy will deploy this project into the Google network and will give me 2 free domains. You don't have to pay for them if you don't need them. They are not so customizable. I mean, they are, if I remember well, they are like something like yourproject.firebase.cloud.com. So it's ugly, but it's free. So why not use them? And it's done. I mean, your app is deployed, and you will be given also a tiny dashboard to see the usage of storage and of the download. I mean, how many people, how many requests you had on your website. And this is very important because you have to stay alert on quotas, because Firebase, I said, it's free, but it's free under certain limits. And these limits are named quotas by Google. There are many kinds of quotas, rate quotas, allocation quotas, but you have to keep in mind that if you go above certain limits, you will start to pay the service. So this was Firebase in short, but I also have something else to show you. If you want to see a real scenario, here I have my website. I bought a domain. It's pretty empty because it's new, but this is my website, and this website is hosted on Firebase. As you can see here, this is my dashboard, and this is my hosting dashboard. As you can see here, I have all the list of all my deployments, and these deployments are done by GitHub Actions. You can create continuous integration pipelines very easily. Now that GitHub Actions are available to everyone, you can create a very simple script like this one, for example. Oops, it's loading. Like this one I created. And as you can see, I go through 2 steps. The first one is building my Hugo website. Hugo, it's a framework. And the second step is deployment. With using a Firebase token, I generated via the CLI I showed you before. And that's it. So you can also, if something goes wrong, you can also roll back. Firebase gives you this feature. You can roll back on your deployments, because, for example, if you deploy something that doesn't work for any reason, don't worry, don't panic. You click this button, and the Google network does everything for you. It's very easy and straightforward to use. So this was me. And last thing, if you're interested, there are a couple of code labs. If you want to learn about how to develop with Firebase. I am a front-end engineer. I'm not a mobile engineer, but I know a lot of people, a lot of friends use Firebase with mobile applications, because there are many features of Firebase you can use only on mobile. For example, app distribution, the machine learning kit works very well on mobile. You can, for example, develop an application that recognizes objects with the camera. So it's very powerful. And remember, it's free. So if you wanted to have some fun, just visit this URL. I will post on the chat now. And there are many code labs free. So enjoy.
Brilliant. Thank you very much, Rossano. Appreciate that.
If you have any questions.
I think we're running so close on time that I'd say save some questions, but afterwards, anyone with questions, feel free for the breakout rooms afterwards, or put them in the chat there. Thank you very much for that. Again, everyone, please show some appreciation. Chuck some comments in for Rossano. And we're going to move over now to Lakshmi Rao on productionizing machine learning pipelines for online prediction.
Yeah, I'll share my screen. You can see my PPT, right?
No, not at this point.
Sorry. No?
You're good. Yeah, you're good.
Okay, cool. Hi everyone, I'm Lakshmi. I work as lead engineer at Tesco. So today I'll be talking about productionizing machine learning models for online predictions. So I'm not a data scientist myself, but I'm a backend engineer. So today I'll be talking about how to productionize the models which are developed by data scientists. So usually data scientists do their training, they build the model, they do the offline analysis, but usually it's in an analytical platform or in their sandbox environment. But now the challenge is how to use those models online. So we know this model is the absolute gold mine. So it is of lot of use, but then to productionize it, there are a lot of components involved. For example, how would you store the model? There are some ETL processes which we need to do to ingest the features which is required for the model. We have to put it behind an API so that we can serve it. And obviously the common things around logging, visualization, scheduling the model, and security. So I would like to go through some of the challenges involved in productionizing such a machine learning model. So the first challenge is the different domains, different languages. So as we know, most of the data scientists use Python as their main language. So most of the code or model they develop is around Python, predominantly around Python. But we as backend engineers mainly use Java or Node.js. So it was kind of like two different worlds, but then it's not like they just throw the model out of the fence and it's our job to deploy. But it was more like we use some of the domain driven concepts like ubiquitous language, so that we understand what both of them say. If they say a feature, then we know what it means, and also what is the input to the model, what is to the output of the model. So to productionize any machine learning model, it's very important that we collaborate between the data scientists, data engineers, and us developers. The second challenge was ingesting the trained data. So to run the model, obviously it needs some input, and that input should be from the trained data. So we have to ingest that trained data so that we can run it online. So those files, for example, are quite big sometimes based on how much data that is used for training. So it could be like 30, 40 gigabytes. And for that, we just built a simple module in Node.js, leveraging the concept of Node.js streams to ingest that data. So to give you an idea of the numbers, even to ingest 30, 40 gig, it hardly takes like 15 minutes. And we are just storing it in Redis so that we can quickly retrieve it with less latency. Coming to the third one, like I mentioned, we had to put this behind a low latency API. So let's call this as the scoring engine, where we have to make sure that the API returns the response quite quickly. And because everything was in Python, we didn't want to do it in Java because of the sum of the calculations had to be done online in Python. But then again, coming from a Java Node.js background, to be honest, even forking a thread in Python is not so easy. So we were thinking about doing async IO kind of API in Python, and we were looking at different libraries. So we came across this AIO HTTP library with GUnicorn, which uses the same concept of event loop, where it doesn't block any request and all the long running requests are delegated to the worker threads. So basically we have deployed this Python as a simple application within Kubernetes. And with this, we are able to achieve really quick latency. The API time is about 20-30 milliseconds. And like I mentioned, we have to do a lot of calculations online, for example, doing some matrix multiplication to give the input to the model. And for that, we just use the right tool for the job. So obviously using Python, and because Python has a lot of math libraries like we know, NumPy and stuff like that. So it was very easy to use Python rather than trying to do it in Java for this scenario. So it's basically using the right tool for the job. Yeah, the most important thing was deploying the trained model itself. So now we have all the data required for the model. We have deployed the API to serve the model, but then the model itself needs to be deployed. There are different options to do this. So we were researching different options. What is the best way to deploy the trained model? One thing is we could embed the model code within the scoring API itself. But as you can imagine, that is tight coupling. So over the course of time, we can't deploy more complicated models if we follow that approach. And also, we could have done the the API in Java itself, because there are some libraries like mleap, ONNX, where we could deploy the serialized version of the model, as in embed the serialized version of the model. But as you can imagine, that option is not that scalable, because you are creating a close coupling of the model with your API. So the best option is to deploy the model as a separate service, so that you just put the model in a service on its own, so that it can evolve on its own instead of creating any dependency with the API. Obviously, you'll have to call that service, so there is some network latency involved, but then it is less. I mean, there is no coupling at all. And also treat model also as data, so that as and when the new models come in, or the same model could be retrained, and it should be very easy to update the models instead of having to do a deployment just to take the new retrained model. So in our case, we are kind of following the combination of second and third approach, where we deploy the model as a service. So for that, we use TensorFlow serving. So TensorFlow serving is one of the components provided by Google to run your machine learning models online. So it mainly supports TensorFlow. At least most of the models developed by our data scientists is in TensorFlow. So it was very convenient for us to use TensorFlow serving. But looking at the documentation, it does support other types of models as well. So it felt like this is the best approach to go, so that we can deploy the models. All you need to tell TensorFlow serving is to where to get the models from. It could be in a repository, for example, or you could embed the models within the same image of TensorFlow serving. It just needs the location to know where to pick the models from. And then from the client, which is your scoring API, you make a call to the TensorFlow serving. So because it uses a gRPC, the calls takes like 2-3 milliseconds to do the predictions. So with all these, we were able to, productionize machine learning models, and we could run multiple models because we got a different TensorFlow serving models, and it was just letting TensorFlow serving know the location of those models. So like I mentioned, we had to achieve a very low latency API because it was online. We couldn't afford to, have a really slow running model running. So basically with this, using TensorFlow serving and having the API with AIO, HTTP and Python, we could achieve the latency of 20 to 30 milliseconds. And because of the gRPC call with TensorFlow serving, it takes like 2-3 milliseconds to do the calls. So just to give you some references, we followed like continuous delivery from Martin Fowler. So it's a very good article. If you are doing stuff like this, I would definitely recommend going through the article. I think there are 4 or 5 articles related to that, and he gives like different options to do. How to productionize the model. So it was a very useful resource for us. And also we looked at some of the machine learning platforms from other big companies like Uber. So those are some of the useful information if you are looking to productionize any model. That's it from me. Thank you.
Brilliant. Thank you very much, Lakshmi. Appreciate that. I'm going to move swiftly on to the next talk, but if everyone can join can put some comments up rather on the chat, and yeah, some reactions and things. But yeah, thank you very much for that, Lakshmi. So we're going to move on. Sorry, guys, we have run over here. We've got 2 more talks left, and then some breakout rooms. I know we're approaching the hour, so if that's all you've got time for, then obviously we understand. In fact, sorry, we've got 3 more talks. So yeah, I'm going to move on to Chris Melikian with GraphQL, an intro and why it was crucial for your project. Chris, go ahead.
Thanks, Barry. Okay, let's get started. So yeah, I'm here to talk about GraphQL and my use of it on a recent project. So about me, I'm a Java developer for 20 years. I've been working in the web a long time. I worked in the finance industry for last 10 years, and last 2 years I was working on 2 public-facing GraphQL APIs, and I'm currently looking for new opportunities. So we're going to talk a little bit about GraphQL, a bit of a comparison with the rest, introduce the schema, and look at how the requests kind of works, and then we'll look at the project that I first did with GraphQL, and then do a quick summary of why specifically it was useful for me. So let's take a little look at GraphQL. So it's a query language for APIs, but it's nothing like SQL. You expose what can be queried or mutated. It implements the CQRS pattern, the command query responsibility segregation. So the input and response model are separate. It uses a schema to define the API. It can be a text file or programmatic. I'll show later why I thought the text file works much better, certainly for us. It originally came from Facebook, but is now managed by an independent organization, which is itself managed by Linux Foundation. And it's used by many, many big companies: Facebook, Airbnb, PayPal, Shopify, and many more. So let's go on to a quick comparison with REST. So GraphQL uses a single endpoint, and it's generally HTTP post only. Whereas REST, you have many endpoints, many HTTP verbs to do all those different sort of operations in REST. In a single request, in GraphQL, you can do multiple queries or multiple mutations. Whereas with the REST, you only have a single operation per HTTP request, really. So GraphQL is much less chatty than REST, less network requests, which can make things easier for a web client. So in terms of data, we're talking about only text with GraphQL. You can use base 64 encoded, text for transmission of images and binary files and things like that. But with REST, you don't have any of those sort of limitations. With GraphQL, you can determine the response. The client can determine the response, so you can exclude certain fields from the response graph if you don't need them, or if they're particularly computationally heavy, you can just exclude them and say, no, I don't want them. And the API can actually tell what you're requesting, and it doesn't have to go and get that, doesn't have to compute that computationally heavy field. It can just leave it out. So you only use the resources you need. With the rest, you basically get what you're given. I would argue that GraphQL is business friendly. It's very simple to read, and that goes a long way if you've got a project on very tight timescales. The business can understand it. It's useful for communicating in lots of different ways. Whereas with REST, you really need to use third-party tools like Swagger and things like that in order to be able to understand your API. In terms of scalability, it's not. I don't think it's as easily scalable as REST, because that single endpoint means you've got no real HTTP caching for particular queries, unless you introspect the request, which itself can be slow. You're really scaling a monolith, but Facebook manages okay, so it's not unscalable. Whereas with REST, you can isolate individual operations like the HTTP gets, and you can also scale individual endpoints differently depending on your sort of traffic. So if we look at a blatantly contrived GraphQL schema that I created, so you can see I've got the file there in 2 columns for space reasons, but we can see a basic input type, sorry, a basic type. So we've got some fields there, some basic scalars that come with GraphQL, like booleans and strings and arrays. So the square brackets there. You have the input types. This is the CQRS part where input types are different to the read types. And we can see we've got nested objects there as well. So we've got the addresses and things like that. So you can create quite complex object graphs there. We can create our own scalars as well. So for well-defined things like, for example, postcode or URL or things like that, you can define your own scalars, which obviously makes the schema more readable, and also allows you to add validation on those types rather than having them as strings. We have enumerations. We have a basic interface concept. So you can define an interface like a customer with a set of fields that are associated with that customer, and then you can have a personal customer or a business customer, whatever, implementing that and having the same fields, which is useful for the queries and mutations. For example, so if we've got a find customer by ID, for example, it returns a customer, it could return a business customer or a personal customer, for example. And here we define our mutations. So we're creating a business customer and returning a result. Okay, so let's look at a sample query and response. So this is a post request to our single endpoint, and we're doing a query for a particular ID, and we're only requesting the fields that we want. So we're not requesting things like in the favorite color or whatever is the pet's name. We only want the name and postcode in this instance. So that saves bandwidth, and it saves the API some resources if it's detecting what it is we're requesting. And there's the result in this particular instance. We also get the type name there, so we can determine whether it's what the type is, not just the interface that it implements. So the project that I worked on was basically a greenfield project to deliver a web app for new customers to apply for a product. Our team built the API, which would be the new strategic platform going forwards. But our fixed deadline was in 4 months. So day 0, had no API dev team, no infrastructure, no design for the infrastructure, no requirements from the business, 6 different suppliers, including external companies, and an external company engaged to build a UI who was ready to go, but didn't know what it is they needed to build. So it was a hard time to start off with, but we forged ahead and didn't give in. So this is a basic timeline of the project. So we started in February 2018. A very small team, just me, solution architect, BA, and a product sponsor. While we were starting the recruitment and getting the design together and things like that, one of the first things that we did was to enable the external company to start developing the UI by getting the schema defined as soon as possible. So the schema was easily prototyped with them in a text editor, and refinements can simply be done by Confluence or email or Jira or even over the phone. We can make simple changes to that text file, and that text file was the schema which we were both using. The external company then used their mock API, or created a mock API based on that schema. And as they continued to build that web API, sorry, that UI, we were then building out our infrastructure and starting to develop our application. We continuously refined that schema, but it's a simple schema. It's a simple text file, so diffs were easy, so you could see what the differences were between a previous schema and a newer schema. So everyone knew what the situation was, that there wasn't many chances for misunderstanding. And when we got to the point of actual integration between our UI and the API, which was in kind of mid-May, the go live date was mid-June or early June, we actually had very few integration issues. There's some issues with data, some data format issues, but really it was a very, very smooth integration. And I think the takeaways from that project were the GraphQL schemas are very simple text files, easy to modify in version, even in Confluence. Non-technical people can understand them and get up to speed with them very quickly and engage with the project much easier. It's one file, so there's no context switching between lots of documents or web pages, trying to work out what it is. When you talk about the API, you can just see it there in front of you. We defined the schema early, and then they could the UI team could get on with their work, and we knew what we had to build. So both parties knew what it is they had to deliver. Yeah, they used their mock API based on that. The changes are easily diffed, as I said, and the tooling was mature on both the client and the server, so we didn't have any issues with the technology as we were building it. If we did have issues, that could really set us back. So, in summary, the GraphQL hastened our shared understanding of our API with the external companies and our business users. That really took out a whole set of problems which could have happened but didn't. The text-based schema was very useful. There's a programmatic schema, but that's not necessarily the best choice, I don't think, especially when you've got an external company doing the UI or many customers using that UI. Text-based schema seems to work very well for us. The client being able to specify the response object graph is very useful, so they could save bandwidth, and we can not have to compute every response field, which is just not required on the client side. So that's very useful. Spring Boot with the GraphQL starter worked well for us. No issues with that. And React.js with the Apollo framework, which implements GraphQL in JavaScript, worked well on the UI side. The project went live on time, and it worked. People were able to spend money with us, which is good. I missed the launch as I caught chickenpox on the week of the launch, which was a slight downside. Yeah, please get immunized. It's not pleasant, but that was a slight downside to the project. But everything went well otherwise, and that's good. A few things you might not know about GraphQL. You can expose your SQL databases as a GraphQL API with a tool called Prisma. Postman supports GraphQL natively. So you can do your integration tests with Postman or also Insomnia. I think I've just lost my keynote. Where's my keynote gone? There we are, back. You can visualize any GraphQL API with Voyager. And there's some other tools as well. So you can see a big graphical representation. You can actually click through your schema in a visual graphic sort of way. You can subscribe to events in GraphQL using subscriptions. It's a very interesting feature. I've not used that yet, but it looks really interesting. And you can also add directives, so similar to annotations in Java for things like specifying authorization rules and things like that. So there's it's quite a rich playground of things that you can do with it. And yeah, I'm ready to take any questions. So thank you very much for your time.
Chris, thank you very much for that. I think I might have to ask you if you're okay to leave the questions to afterwards in the breakout session if anyone's got them. Just desperately worried about running out of time on this one. But thank you, really appreciate that talk, Chris. Again, please put the comments in the chat there for Chris. And Ilan, do we have Ilan out there ready to talk about WebAssembly?
Can you hear me?
I can hear you. I'll hand straight over to you then.
Oh no, it's trying to share the wrong screen. How do I make it? There we go. Share that screen. Okay. Tell me when you can see my screen.
Yeah, all good.
Good. Okay, so I'm going to try keep to the lightning talk times. So hopefully the next guy will get to speak. I'm going to be talking mainly about WebAssembly. Who am I? I'm a human being. Been a human being for at least the last 20 years, and I can be found on planet Earth, which is on the edge of the Milky Way. You can also find me on GitHub and LinkedIn, and I am the only Ilan Pillemer in the universe. So Google me if you want more information. I didn't go right. So I'm going to try cover in 5 minutes. Briefly, what I've been working on in the evenings. I try talking my talks about current research I'm doing. I work in research development and engineering. So I try in the evenings to be doing research that isn't the stuff I'm working on professionally. Okay, so I'm going to talk about the In5 model quickly because that's what inspired me to do the project itself. But I'm using WebAssembly together with D3, Google Auth, and Vugu to build what I'm currently looking at, which I'm just going to walk you through. So what's the In5 model? The In5 model looks at our 11 systems. We've got 11 physical systems, circulatory, skeletal, respiratory, etc. They're all involuntary. In order to be healthy, those 11 systems need to be in good balance. But we've got 5 controls, which are, if you look at my app on the left, you can see them also on the star. They move, engage, eat, cogitate, and sleep. They're the 5 essential things, and take any one away from us, it's considered torture. So they're important. And if you do those things, you affect your circulatory system, so you should be able to tune them, and you can make normal better. There's a whole movement currently in the UK, and there's sponsorship going on. Some professors have been given a lot of money for that. Okay, so I built the app using WebAssembly. What is WebAssembly? WebAssembly is a virtual machine that runs in the browser. It was designed so you can write compiled languages. You can see on the left there, C, C++, Rust. What don't you know? What do we know they don't have? They don't have garbage collection. But we're using garbage collection languages. I'm going to show you what I'm going to show you in Go, but Java is also a garbage collection language. Now, quick demo. So on the left here, you can see a file directory. I'm just going to point out the important files for WebAssembly. There are 3 important files there: WASM exec.js, index.html, and the third file you can't see because it doesn't exist. WASM exec.js, I'll show you that. My screen types. Emacs, what's that provides thing global.go, and this allows the Go main WASM to interact with JavaScript. So The second file is index HTML. So I will show you that. Trying to be fast. The only important lines here are these 3 lines over here. The rest is just boilerplate for errors and things, not those 3 lines. These 3 lines. Essentially, the index HTML is using that Go thing that provides interaction with JavaScript and your WebAssembly binary, and it starts streaming it and then takes over and starts all the rendering in the browser. The main.wasm itself, let's create it quickly. Yeah, there it goes. And now I've got a main.wasm. If I were to cat it, it doesn't look very pretty. That's what the binary looks like. However, what you can do is you can get it into assembly format because it is WebAssembly. So if I were to cat main.what, that's what it looks like. It's pretty ugly, and I'd be surprised if anyone wants to write this kind of, looks a bit psychedelic at times, and I'd be surprised if anyone wants to write this manually. So you don't really write this stuff manually. It's a bit like a Java virtual machine. Some people do, I guess. Okay, so those are the files that run in the browser. If you look on the left-hand side, you can see the apps running, and you can see those files are all there, main.wasm, and the other ones. I want to talk quickly. So I just wanted to show you exactly what it is. So something produces that file, that main.wasm file, the WebAssembly file, it goes to the browser, as you can see over here, and then there's interrupt with JavaScript. The problematic thing here is it's interrupt with JavaScript, which means that JavaScript speaks for WebAssembly. WebAssembly can't communicate with anything apart from the JavaScript, and the JavaScript communicates to the WebAssembly, and there's no shared memory. So that's difficult. WebAssembly is going to have more versions in the future. It was created in 2015. 2017 it was when it hit MVP and it arrived in all the browsers, all the 4 major browsers. The next thing is I want to be using D3.js, but D3.js, as I said, is JavaScript. On the right-hand side, I've got an example of what D3 does to produce the graph you'll see when if I sign in. So I'm going to sign in quickly on the right here, sign in as myself. And you'll see it re-renders with that. This is a single page app, then you can see the D3.js graph. It's very simple. There are 2 lines. There's a line there and a dotted line, green line. You can see that's 25 for the BMI, which is a good indication of whether or not you're overweight. I can see I'm overweight. That's not good. I should manage that. Go to the next slide. Okay, so Google Auth, again, you can see there's JavaScript. So if I'm doing Google authentication, you just saw, once it comes back, I need to be able to update my status, but my status is in Go. So I've got to communicate across to the WebAssembly for it to even know about it. There's no shared memory. So what I'm doing is I'm using something called Vugu, which is based on tools like Vue, React, and Angular. It's experimental. It's in heavy development right now, and it's only partly documented. I'm big into exploring the tools that are coming on the leading edge. It allows you to write your UI component, something called Vugu files. So you can see on the left here, I've got my application running using Materialize, and it's all based with components written in Vugu files, as it says there. So let me show you some of those quickly. So I'll go into the app. You see I've got an app.go. This is where I'm keeping my global state, such as that I'm logged in. Then if I were to go into my components, I'm going to choose the root, for example. Let's see that a bit more prettily. So you can see it's got the whole, this is the whole application. You can see it's built up with components. So I've got the star that you saw earlier if I'm not logged on, and I've got logged on, and I've got the BMI if I am logged in, and they are separate components. And then if you go into this, BMI now I've got slightly prettier. So you can see if I'm logged in, it shows it. Otherwise, it's not going to show it. And I draw the BMI. Now you can see I've got to call out to JavaScript. So here's the example of calling out to JavaScript, this line here. I've got a JavaScript method that now my WebAssembly has got to actually communicate to. This is the most difficult bit to deal with. Once you're working within either JavaScript or in Go or in whatever language you're using, it's much easier. The last thing is I'll show the really tricky part is the getting JavaScript to call you back with a callback. So I will, and I think I went into the wrong file. So that'd be into the navbar, put the colors on. And you can see here, I've got to now refer to an existing JavaScript method, update state. I've got to set the callback, and I set the callback to a method that I've got called update state over here. I'm not going to dig into it. If I go back to my slides, you'll see earlier in the JavaScript one, this is the callback. This is a callback that I just showed you. I'm talking fast. I hope you followed. Maybe you didn't. Here are the resources that I've used. There's the GitHub repository. All the code is online. It also uses Travis CI. It uses GitOps. It deploys to Kubernetes. It uses only open source. The DigitalOcean is costing me about $15 a month to run this, plus blogs, plus other things and everything, and they can't charge me more than I expect. So you can't suddenly worry about rates like you have to, I suppose, with Firebase. These are YouTube videos of the recent WebAssembly conference that was held last month or 2 months ago, and various other things. And then here's all the future. Wow, future. Okay. So as I said, my name is Ilan Pillemer. I'm a human being. You can find me on GitHub and LinkedIn, and I'm the only one of me ever. Thank you.
Thank you very much, Ilan. Appreciate that. Appreciate that.
Hope I kept to the 5 minutes.
Not quite. I think over 10, just over 10.
No.
I think do you know what? We definitely need to not book 8 talks in and try and squeeze them all into an hour next time. So, but thank you very much. Appreciate that.
Or you have an automatic cutoff, so it just cuts at 5 minutes.
I couldn't do it. I just couldn't do it. But anyway, thank you very much. Any comments, please put them in the chat bar. Appreciate you doing that. And finally, Karsten Silz with Google Jib. Karsten, you out there?
Yes, I am.
You are brilliant. All right, well then take it away. I'll leave it with yourself to finish it off.
Okay, if you make me the presenter, I'm trying to share my screen.
You had any luck there? Yep, there you go. Yep, got it there.
Okay, so well, thank you, Barry, for the introduction. Last talk today, I want to tell you how you can produce smaller and faster Docker images for Java applications with Google Jib. So why should you listen to me? Well, do you create Java Docker images by copying jar files into the image? And do you want to save time and network bandwidth when you're doing that? And do you also have the ability to change your Gradle or Maven build process? Well, if the answer to all of the question above is yes, then you should take a look at Google Jib. Why? Because it gives you smaller Java Docker images and leads to faster Docker pushes. Now, before we can turn to Google Jib, we need to first talk a bit about Docker files and layers. So when you write a Docker file, this Docker file creates Docker images. These Docker images have multiple layers. Now, most Docker file lines actually create a new layer, and Docker stores and caches these layers individually. So now when one layer changes, then all the following layers also get rebuilt. Now, there was a lot of talk about layers and images, so let's take a look at a sample Docker file. So here's one. You start out with a base image, a Java 11 JRE here. You create a directory. You make it a work directory. You set an environment variable, you copy a shell script into the image, you copy your jar file into the image, and you make your shell script executable and run it. And that's the entry point for your image. So this is your Docker file. Now, how many layers will that create? Okay, let's take a look. So first one, your base image is a layer. Your makedir command is a layer. You're running the workdir. Making it work there is a layer. Setting the environment variable is a layer. And as you can imagine, everything else is a layer as well. Okay, so now we have our Docker image consisting of 7 nice layers. Now let's assume we want to push that to a Docker repository. So what happens? Well, as you may imagine, all 7 layers get pushed across to the repository. Our image, 7 layers, all 7 layers get pushed. Now let's assume we make a change to our application. So we just change one Java class. What effect does it have? Well, we have a changed class file, but some of the resources change as well. You know, we've got some build info with timestamps in there. Our web application probably gets rebuilt. So as a result, we have a completely new jar file now. How does that affect the image? Well, the first 5 layers, they don't change. Nothing changed there. It's only layer number 6 that changes because that's where our jar file is. And then layer number 7 changes as well because you may recall it changes, it gets rebuilt because the previous layer did change. So how does that affect our image? We still have an image. 5 layers didn't change, 2 did change. Now you can take a guess at what happens when you push that image out. Well, layers number 1 and 5 don't get pushed. They're still in the repository. They haven't changed. They don't get pushed. It's only layers number 6 and 7 that get pushed. Again, only the 2 changed layers actually get pushed. So just to recap, every change that we do results in a new jar file and in a new layer, and that new layer pushing gets pushed each time. That wastes a lot of time and bandwidth. There's got to be a better way, and there is. And this is where Google Chip kicks in because it unpacks the jar file. Now, what is Google Chip? It's an open source Docker image build tool from Google. And here's my cat. It minimizes Docker image layer changes. It provides you with Gradle and Maven plugins. Also has a Java library. And you can configure it instead of writing a Docker file by hand. It can actually also build Docker images without a Docker daemon, but I haven't explored it yet. So how does a Docker image look like that Chip builds? Here is a sample one. So as before, you start out with a base image, but then you only have 4 layers on top. Number 1 is you have a folder called applibs, which, as you may have guessed, contains your dependency jar files, you know, your Spring Boot and all the other libraries. You've got your resources, your data file, your web application, your data file, configuration files, all in layer number 2, the resources folder. Layer number 3, called classes, does contain your classes. And layer number 5 contains the extra files, like your shell script. So if you were to push that image to a repository, all 5 layers get pushed, as you would expect. Now, just as before, you change one Java class. This one class file changes, resources changes, but now only 2 directories change. So what does it mean? What's changing in the image? Well, the dependency jar file and the base image doesn't change, but the resources do. So layer number 3 changes, my class changed, so that's layer number 4. And the extra file didn't change, but it gets rebuilt nevertheless because the lower level changes. So I push 3 layers. Okay, well, so now what's the big deal compared to pushing my jar file? Well, these layers are much smaller. Well, how small are we talking here? Let's look at an example of an application that I'm currently working on, a pre-production Spring Boot Angular web application. I looked at how much data gets pushed when I just change my classes or a resource, you know, like a web application, and how much data gets pushed if I change a Java dependency. Now with the Docker file, it doesn't really matter. It's 124 MB either way, and I have to push that each and every time. Now with Chip, it's different. If I just change a class or just change my web application, then I only push 7.5 megabytes. Now, if I make a change to my Java dependencies, I also actually push a little more than with the jar file. Why is that? Because the file, you know, jar file is compressed, and with Chip, everything is uncompressed and lingering around the file system. So I guess that's why it's a little big. But, you know, let's take a look at the savings. If I just make changes to my Java or the web application, don't change dependencies, then I save 94% of the bandwidth. You know, instead of 124 megabyte, I just push out 8. So I'm saving 116 megabyte there. If I change my Java dependencies, I pay a little penalty, but it's just 4%. It's about 4 megabytes. So what I've shown you is that Docker usually pushes 90+% less data when you use JIP compared to just your good old Docker file with a jar file. So why is that? It's because the changed layers are smaller in JIP, and that gives you faster pushes with Docker. And this leads us full circle, because as I said at the beginning, Google JIP gives you smaller Java Docker images and faster Docker pushes. If you want to find the slides and the source code for this, then please go to my GitHub repository. You've got the QR code here, you've got the link. The documentation isn't complete, so if you want to change the application or use it in your own project, you'll find the documentation there by Monday. Barry, back to you.
Brilliant, thanks Karsten, I really appreciate that. And what a great way to finish. So thank you very much, and thanks for everyone that's tuned in. Please add some comments to the chat for Karsten and any questions. So we're going to finish now with some breakout rooms. So I had envisaged this would be about 35-40 minutes earlier, so I don't know if all the hosts are still happy to stay or not. So host, you'll have to let me know. But we should have, if Zoom is going to do this correctly, 4 breakout rooms, again, if hosts are around, on running Java in production with Docker, cool data structures, microservices, and JVM and application performance. So if you are still interested in sticking around for a bit more chat, then feel free. I'm going to hit the breakout buttons now. Yeah, I'm hearing from a few people to say they're still good. So I'm going to hit the breakout rooms anyway. I'll put the details in the chat for everyone to see. So let me put these. I think they're there. So they're the rooms that we should have open. So if you want to join any one of those, then just let me know and I can put you in the right room. But thanks to all the speakers. Thanks to everyone that's tuned in and given it a go. And yeah, hopefully we'll see you in a couple of weeks for the next one. And as I said, please join the group if you're interested in joining up with other aspiring speakers. Cool. I'm pressing the button now, so I'll see some of you soon. Cool. So you should hopefully be assigned. Do I need to assign? Okay, this is the first time we've done it this way, so I think maybe I need to assign. Yeah, certain people. So there you go. So you have to let me know if you want to be assigned to a group. You have to let me know either directly on the chat or just put it on there. Just put it on the general channel.